with that said, let's start doing chapter 11, because from this point forward, that's what you're going to start seeing on the exam. I gave you guys a little bit of guidelines here on what can help you. So up on the top here, it says when you multiply like bases, you're going to add the exponents like we talked about yesterday. And when you divide them, you subtract. So there is one, just like number 1 here on your exam. What would I do with x to the 8th divided by x to the cube, x cubed? I would subtract these exponents. So I would have x, I'm actually going to write it out for you so you know what we're doing to help you on the final. 8 minus 3, that's how I'm getting this number. I'm doing 8 minus 3, which is what? 5, and you're done. That's your answer. Okay, so that one is just like number 17 or 18. I forgot which one it is. Now let's do another one. Let's just do the x's first. I have x to the 7 minus 2, and I have y to the 1 minus 2. So if you see here, when you're adding and subtracting the exponents, you can just write them up here to help you out. If that helps you to write them, then do that. Otherwise, if you know how to do it without, you don't have to do that step. But now let's go ahead and finish it off. I heard Micah say x to the 5th, and you're right. Now, this one is y to the what?
Negative 1. But negative exponents can't exist, so
it can't.
It becomes a denominator.
It becomes the denominator, yes. So, and I'll explain that in a second, and that's very true. And I want to do it this way for a reason, because in the future, in the next chapter that we talked about, when we have a negative exponent, that really means that it actually goes to the denominator, because negative 1 would really mean 1 over y. So really this is x to the 5th over y, and we're done. Now, could you have done it a different way? 100%. You could have said, okay, 7 minus 2 is 5. I go right here. Okay, well, I know that I have 2 on the bottom and 1 on top. Well, that means that only 1's going to be left, and it's going to be on the bottom. If you can logically think that way, that's fine too. I'm just trying to show you the mathematical way of how you would actually show your work if you wanted to. But if you knew that the y was going to remain on the bottom without doing all that work, by all means, please do it. I always encourage you guys to do it if you know how to do it in your head. Okay, I'd like to see that stuff. Questions on those two? You sure? Again, this is your time to ask questions, because this is your study session. These are study sessions now. These really aren't even, I'm not teaching you. I'm studying with you. Okay? Here is that claw. Remember the claw I used to talk about? The claw. The first, outer, inner, last. First, outer, inner, last. You guys like these. It's the reverse of, it's the reverse of factoring. Okay? So we just do the claw. We're actually multiplying. So in red, what is x times 2x? I heard it from Julian, I think 2x squared. Okay? And then in green, x times 5. 5x. In blue, remember, here's where people go wrong right here. This negative is included. Negative 3 times 2x. Careful. 6x. Yeah, careful. Nope, that's very common. Don't feel bad. Okay, negative 3 times a positive 2. Then we have let's do pink. Negative 3 times a positive 5. Very good. Do you have questions on any of those colors? You can tell me what color confused you if it did. That's my little claw. I think of Mr. Krabs. That's what I was thinking of. Now I have one final step, and that's just to combine like terms right here. This piece. The best part about a final exam that I think, yes, you don't get partial credit. You can see right away if you went wrong. Okay, if you looked at the answer right now, you'd be like, oh, that's not the answer. Got to do something else. Okay, when I do 5 minus 6x, what do I get? Negative 1x, or just negative x. You'll see negative x on the exam. You won't see negative 1x. That's why I'm going to write it this way. But it would be accepted. It's the same exact thing. I want you to take a minute and do number 4, because it's exactly the same thing. Do number 4.
Something about Miss Miller that Rachel wants to talk about.
So in red, I had 3x times x, which you guys got 3x squared if you did it.
Plus 6x.
Not 6x.
18.
Plus 18. Wait, no. You're at the end. No, you're at the end. You guys are doing the end. I'm not done yet. Then I have negative 1 times x which is negative 1x, or just negative x. Wait, what part were you confused on, Abby?
I instead of I meant
Positive and 6 is positive, so they're both can be positive. Then here I have a minus 6. When I combine these two, I do get 17x. So good job for those that completed that correctly. Okay, we're already halfway there. Go ahead and flip when you're done, please. And if you have time, like you finished earlier than everyone else, you could have that packet out and start working on the problems that you have to do. That's 100% okay if we're not talking. Okay, so go ahead and get that packet out, and if you finish the ones I asked you to do earlier, then you can work on the ones that you have to do. Okay, right here, I thought it would be really helpful for you, because when I was looking over those 098 tests that you guys took, which should be to you tomorrow, I felt like this would be helpful right here for those that struggle with radicals, which is majority of you. Not all of you, but majority of you. Okay? Make a factor tree was number 1. Number 2 was to circle your pairs. 3 was to pull out one number from each pair and then multiply. And 4, the number not circled or a letter, you need to stay inside. So that's a breakdown if you struggled with this, which again, some of you did. So look and reference this if you need to for radicals. Okay, so, but do we know this? What two numbers break down into 81?
9 and 9.
9 and 9 because it's a perfect square. So boom, done already. There are 1, 2, 3, 4, 5, 6, 7, and 8. If you did not need to do this, then you don't have to. If you don't have to do this, it's okay. You don't have to write all this out if you know what it is. If you know the square root of x to the 8th is x to the 4th, then you're good. It just depends on who you are. If you knew that 8 divided by 2 would also get you the answer, that's fine too. It just, everyone's at a different level at this time, I think. Some of you can go right to the end without even showing any work, and some of you can't, and that's okay. It just, as long as you keep working towards it. So my final answer would be 9x to the 4th. Why? Because I have one group of 9 that came out, and in blue I have 1, 2, 3, and 4 groups of x's that came out, and that's why we get that answer. We just worked on these, so hopefully it's a little bit easier for you. Hey, sorry. 1, 2, 3, 4, 5, 6, and 7. 1, 2, 3 groups and 1 stays in. Same thing with this guy. 1, 2, 3, 4, 5, 6, 7, 8. Some of you do not have to write all this out. Again, it just depends on who you are. Can someone tell me the end result? Go ahead. Julian, go ahead. What else? There's something left. What's up? Something's left inside. Anyone? Go ahead. Root A.
Is that 2 supposed to be a 3?
Oh, sorry. You're right. Relax, everyone. Sorry. A cubed, b to the 4th, square root A. Okay, here's why. It's all good. 1, 2, 3 groups. 1, 2, 3, and 4. That's why the 4 is with the B and the 3 is with the A, and the A stays inside. Okay? So, some of you, though, did not have to do that, and I hope that eventually you get there. If you think about it, 7 divided by 2 is 3.5. So that's why 3 of them come out and 1 stay in. If you think about it this way, 8 divided by 2, 8 divided by the index of 2 is 4, and that's why we get b to the 4th. Either way works, just depends on who you are and what situation you are currently in. Okay, I'm going to challenge you guys to do 7 because we've been doing this for so long. I want you to break this down. Go ahead and give it a try. I don't even care if you just do the factor tree and that you get stuck. That's fine. Do something. Get there. You should be able to break down 48 into its prime factors. Numbers multiply to get 48. 8 and 6. Okay? Then this breaks down into 4 and 2. And this breaks down into 3 and 2. This also breaks down into 2 and 2. I personally like to cross off things that I break down because it makes me organized. I have one group of 2 and I have another group of 2. But don't forget that 3 stays in. How would you write the numbers now? Like how would you write the numbers? Like what comes out? The 2 2's. So 2 times 2 is how I'm going to write that. Let's talk about the x to the 5th. How many x's can you pull out of 5?
2 groups.
I can pull out 2 groups. And how many is left inside? 1. I'm going to write the 3 and I'm going to write the x. There would also be a y. Very good. How many come out? 1. Final answer, 4 x squared y, 3xy. Now, some of you are getting really good at doing that in your head, and I'm happy, because that's how I do it. When I set up this problem, last one, but now my index is 3. When my index is 3, I no longer circle groups of 2, I circle groups of 3. So, I have 8 and 8. Yep. It is 4, and we'll see why. Well, it's not the square root of 64, it's the cube root of 64. Okay, so let's talk about that. This also could be 4 and 16, which also breaks down into 4 and 4. You can keep going, but look at what Edward's saying right now. I have a group of 3. Why keep going and put yourself through the pain? Phone's away. So that 4 is now going to come outside my radical. And this is kind of how I do it. Like I said, I have like a little radical off to the side knowing what stays in, but no numbers stay in. Now, here's how my brain works. M to the 6. How many times can I pull out groups of 3?
2 times.
2 times. Here's why. Because 6 divided by 3 is 2. Now let's talk about this one. This one's a little bit more tricky. 7 divided by 3.
2.5.
2.5, 2 point something. So then I would have n squared with 1 n left inside. Very good. Here's how we got that. 2 times 3 is 6. But there's 7 n's, so 1's got to stay inside. Okay, so hopefully you're getting better at that. I'm going to skip 9 because to sake of time, I want you guys to work on it, the homework portion in class. Remember, if there's a number here like this guy, that's the ones you're doing. I think there's only like 5 today or 4. There's only 4 today. You have 4 questions, 17, 18, and you have 19 and 20. That's it. So we have time to work on this. I'm actually even going to go ahead and skip 10. Just for the sake of time, because I want you to ask me questions on what really matters, and what really matters is that packet with the multiple choice. Multiple choice, in my opinion, is your best friend or your worst enemy. You can figure out your answers 90% of the time given your choices. Okay, you know if you got it wrong or not because you have choices available. Okay, so make sure that you're using that to your advantage. This one, we just did it earlier, but now there's radicals. Do you remember what happens when you have the same exact radical? They basically cross out, but let me write this out for you so that you understand. Really, this means the square root of 10 times 10. Because whenever you multiply, you have to multiply the insides together. Okay? But I'm just going to keep going with that. Then I have, in red, plus 5 square root 10. Because you can't multiply 5 times 10. Because one's in the radical and one's not. So be careful with that. It's like having a variable. It's like if this was x, your answer would be 5x. But here we just have a radical. You're treating it like a variable. Here I would have negative 2 square root 10. And then here I would have, what's negative 2 times 5? Very good. Okay, so here's where we are. Do you have questions on any piece of that before I move on? It's the last one of the day, so you can ask me a question here. It's like the radical is a variable when you're working with numbers and radicals. Now look, we have a pair already, or 10 times 10 is 100, and the square root of 100 is 10. If you have a pair, it comes out, right? Okay, then everything else. Let's talk about this. If I had right now, off to the side, don't write this, 5x minus 2x, what would you say the answer is?
3x.
3x. It's the same exact thing, But this time, it's going to be 3 radical 10. It's like that 10 is a variable. You can't do anything with it. It's just kind of there. Bring down your minus 10. Do you notice something that happens?
The 10s cancel.
The 10s cancel because look, 10 minus 10. So my final answer is 3 radical 10. Okay, you have 4 questions and a lot of time.